In my last video, I talked about replacing the tube in one of our cold spare backup transmitters. Let's recap what happened next.
After installing the new tube, we were ready to make performance adjustments to the transmitter. These tube-based power amps are not machines like MOSFETs are. It's almost like they're living things. Every tube performs differently. We took the drive chain all the way down to 0 watts and started bringing it up from there. But once the intermediate power amplifiers, or IPAs, got over 100 watts forward power, they started shutting off because of too much reflected power from the tube's grid input.
That's when we knew we had a problem. If you remember from my last video, we ran the transmitter on the old tube before taking it out, and it ran just fine despite not being able to make full power. So we put the old tube back in. The same thing happened, so it was time to troubleshoot.
First, we wanted to make sure the drive chain was in good working order. These HPX transmitters have a way to connect the IPAs directly to the main RF output of the transmitter, bypassing the tube. This would allow us to test everything on either side of the tube, including the second harmonic notch filter inside the PA cabinet.
I was able to get the IPAs to push the nominal 540 watts from our factory test data without the tube input, so we could then definitely rule out everything except the tube. After 3 days of testing different things and a couple of calls to Gates Air support, I broke out my clamp ammeter.
There is a transformer that takes 208 volts AC down to a high amperage 10 volts to heat the cathode in the tube, which is required for thermionic emission. After a filament on command, I measured the current on the transformer's primary, 0.2 amps. That's not enough. The socket the tube sits in is composed of these concentric rings of finger stock contacts.
While I looked for spare rings to replace the cathode contacts, our engineering director went back to inspect the ones that were already installed. He touched one and it sprang out from where it was caught on the lip of the opening in the tube cavity. We'd found the problem.
After he spent a few minutes carefully freeing the finger stock contacts, we were finally ready to install the new tube again. This time, I measured 12 amps at the primary side of the filament transformer and we were good to go. It was almost like we got a do-over of the new tube ramp-up procedure, which I found helpful.
In part 3, I'll go over some of the final tuning procedures we use for these tube-based transmitters. In the meantime, did you know I also have a YouTube channel? It's linked in my TikTok profile. Some folks have said they wanted to send my videos to people who don't use TikTok, so I've put most of the educational videos there as well. Follow for more broadcasting content.